Millennia ago, space was nothing more than an empty, lifeless void, the only activity originating from within its celestial objects. The invention of the hyperdrive engine dramatically changed this dynamic, and today, the void of space is a bustling thoroughfare, supporting many interstellar travellers. The most densely populated area, spanning 11 regions and containing the largest and oldest community of interlopers, is the Galactic Hub. Within this amazing community bloomed an insatiable curiosity for exploration and building, which contributed to the rapid growth of their vast domain. The Kujisa system, nestled in the Savanax instability of hub space, contains some of the community's lesser developed planets, all 6 remaining mostly untouched from building activities. Maintaining the closest orbit to the system's twin stars is Shoba 70Y5. Lacking any interference from the galaxy's dominant species, the planet has become wild and overgrown, its luxurious grasslands supporting a thriving wildlife population. Bioluminescent trees and shrubs flourish in the humid conditions, undeterred by the superheated rainstorms that drive the already tropical temperatures to a scalding 100 degrees Celsius. The allure of Shoba 70Y5 is the beauty of its plants, among which a particularly rare species of grass dominates the landscape. Praxifolia. Seeming to fluctuate between green and pink during the day and blue and yellow at night, its true colour remains under speculation. Its hue changes depending on the proximity in which it is viewed, an effect that is evident even when observed through technological lenses. These damp, ever-changing grasslands are home to one of the system's most unusual creatures, the Begurkium. Fully adapted to the human environment, the Begurkium is Shoba's apex predator, sitting unchallenged at the top of the food chain. Despite their encumbersome size, they move with surprising speed and poise across the uneven terrain, able to outpace even the swiftest of prey. They are incredibly successful hunters, relying on their cunning and speed to ambush and secure kills. A serrated beak, capable of up to 3,000 pounds of bite pressure, is able to make quick work of any meal, and they devour their kills completely, leaving not even a skeleton behind. This carnivorous diet is supplemented by feeding on the Praxifolia that carpets the planet, the high fibre content helping to aid their digestion. Although the most well-adapted of Shoba's native species, Begurkium's population is relatively sparse, with only around 500 remaining in the wild. They spawn rarely, reproducing asexually through a process known as budding. The offspring develop slowly within the protective crystal pods located on the creature's shoulders, dropping like fruits when they become sufficiently developed. Begurkium are fully independent from birth, and due to the sparsity of their population, they may never come into contact with another of their species during their lifetime. Alongside Begurkium, Shoba 70Y5 supports a diverse variety of flora and fauna, whose origin can be dated back millions of years. This is the case for 5 of the 6 planets contained within the Kujisa system. The 6th planet, however, is another story altogether. This is Shattered Barriers, a planet that until very recently was known to be desolate and empty, its conditions unsuitable for the evolution of biological life. Around 40 years ago, an orbiting science telescope detected the appearance of strange metallic-looking structures forming on the surface of this planet. Intensive surface scans revealed that a great transformation was underway. The air was becoming less toxic, and the presence of strange architecture more pronounced. This is the work of Sanguine Bua, a recently discovered void-born species that spans the vast reaches of the Euclid Galaxy. Having no native planet, Sanguine Bua freely travel the expanse of space, settling only on vacant planets empty of biological life. On finding a suitable planet, they begin construction of strange tower-like structures, thought to facilitate atmospheric changes within the planet's biosphere. Although mechanical in design, these structures are entirely biological in composition and disappear shortly after their work is completed. Over a surprisingly short period of time, using these structures, Sanguine Bua terraformed the empty planet, making it suitable to sustain carbon-based life. Study of the processes employed by Sanguine Bua is proving difficult, owing to the incredible secrecy in which they operate. When observed, they will halt all construction, becoming docile, only resuming work when they are sure they are alone. If left unobserved, the work progresses quickly, transforming the atmosphere into a livable, life-sustaining environment. It is at this point that they depart, along with their structures, searching for the next empty planet. The work on shattered barriers is still in its infant stages, and it is estimated to be completed within the next decade or so. On completion, microbial life can be introduced through chance meteor strikes or by scientific intervention. Regardless of the delivery method, over thousands of years, life on shattered barriers will look very different. A once empty, desolate planet, now flourishing with the gift of new life. The development of complex life forms require a delicate recipe of circumstances that unfortunately not all planets can provide. Some planets, like Shoba 70Y5, are well appointed, and its life forms have specialised over millions of years to thrive there. Shattered Barriers, on the other hand, was not originally equipped with the necessities to support life, but is now being given a second chance to sustain an ecosystem all of its own. We hope you have enjoyed this documentary. Please like, comment and subscribe to support the crew on the next adventure. Have fun, stay safe, and more importantly, be curious. With interstellar travel being more accessible than ever before, spacefaring civilizations have spread far and wide throughout the Euclid Galaxy. The Galactic Hub, the oldest and largest of these civilizations, accommodates 11 regions and contains the most developed systems of known space. Nestled in the Euclid Nebula of hub space, the Tisuohe-Cring system contains 5 planets and 1 moon, inhabited exclusively by interlopers of the Galactic Hub. No major Gek, Viking or Korvax settlers dwell within this system, and it remains devoid of any space station or interstellar trading posts. Being one of the lesser populated areas of hub space, the native wildlife can thrive mostly uninterrupted on their home planets. This is Later Beta. Though it maintains the farthest orbit from the system's M-class star, Later Beta boasts the most extreme heat of any planet in the system. Temperatures here average around 50 degrees centigrade, exceeding 100 degrees during the planet's infrequent firestorms. In spite of these harsh conditions, a diverse variety of life has taken hold, creating a rich and full ecosystem. Tall, heat-resilient plants cover the rocky ground, casting much-needed shade onto the small shrubs and grasses that serve as the primary food source for many of the planet's creatures. To cope with this excessive heat, the majority of the species here have evolved to be small in stature, a trait that facilitates efficient heat dispersal, keeping them cool throughout the day. One of Later Beta's species, however, evolved a little differently from the rest. Rattus dudima, Later Beta's megafauna species. Towering above its fellow herbivores, this species can reach heights of up to 5 meters. Their bright, somewhat glossy exoskeleton deflects both light and heat, enabling the animal to maintain a comfortable temperature. Later Beta supports a crowded ecosystem, and for the widespread population of Rattus dudima, this can make finding a mate challenging. Vibrant colouring and gigantic proportions makes identifying each other from vast distances much easier. Their distinct outlines easy to differentiate from those of the planet's other grazers. This is extremely important as Rattus dudima are an inherently lazy species and will only exert energy when absolutely necessary. They live slow-moving solitary lives and as a precocial species expend very little effort in raising their young. Rattus dudima females lay a clutch of up to 6 eggs, burying them below the surface, in the cool soil surrounding groups of solar vine. During periods of extreme heat, some females choose not to expend their energy burying their eggs, the balmy temperatures perpetuating their laziness. Instead, they leave them on the planet's surface, making them easy prey for the planet's various egg predators. Recently, Later Beta experienced its hottest decade, a period of time in which not a single Rattus dudima offspring successfully hatched. This led to a dramatic drop in their population, and the species are still recovering from its effects today. Rattus dudima share the planet with a remarkable array of animal species, all perfectly adapted to thrive in the superheated conditions. Elsewhere in the system, it is the complete lack of heat that poses the biggest challenge for survival. This is Tunas, the Arctic moon of another of Tisuohe-Cring's planets, Ichthys Omega. From the moon's surface, Ichthys Omega's rings are visible, lighting up the moon's icy skies with an impressive display. The frost-hardened ground is surprisingly fertile, supporting dense forests of evergreen trees, along with smaller shrubs and grasses. These trees produce protein-rich leaves, providing huge amounts of energy exclusively for Tuna's megafauna species. Formibro. Taller even than Rattus dudima, Formibro can reach heights of up to 5.8 meters. This height advantage allows them sole access to a treetop buffet, consisting of only the freshest of leaves. A thick, blubber-like skin helps them to trap heat, keeping the animal warm in temperatures as low as -94 degrees. This requires a lot of energy, and each day, a single Formabro will consume its body weight in leaves. With each animal weighing an astonishing 262 kilograms, feeding can take most of the day, the creatures moving slowly to conserve as much energy as possible. Luckily, food is plentiful, and the species experience no competition from the other grazers, whose diet is made up of the planet's low-growing grasses and shrubs. Formabro are relatively rare, and as such have evolved to be hermaphroditic, allowing them the best chance to reproduce with any partner they find. After copulation, each mating partner, now carrying a child, goes their separate ways, searching for a sheltered place to birth their young. The parents take great care in raising their infants, helping to feed them whilst they are too small to reach the treetop leaves themselves. Animals on both Tunis and later Beta have overcome environmental challenges to survive in harmony with their home planets. On Ranto 2, the threat comes from an entirely different source. Being the third planet from Tisuohe-Cring star, Ranto 2 boasts incredibly stable conditions, experiencing very little environmental disruption. Small lakes and streams break up the desert hills, providing plenty of drinking water for the planet's inhabitants. 11 vegetarian species wander the plains in the comfortable 30-degree temperatures, grazing on the many species of cacti littering the planet's surface. All of them live cautious lives, always aware of the impending threat presented by the planet's formidable megafauna species. Rhinomia. Barbed tentacles laced with a powerful neurotoxin snatch at prey from underground, incapacitating any that cross its path. These tentacles can reach lengths of up to 6 meters and are strong enough to carry even the heaviest of prey. Seemingly endless endurance means that they can give chase for a number of days, waiting for their quarry to tire before going in for the kill. The animals here have each adapted their own special trick to avoid capture by Rhinomia. Tapir-Bium, the most common of Ranto's grazers, uses its many metal-tipped legs to cause disruptive vibrations on the surface, in an effort to confuse any nearby predators. Should this fail, they are able to exert a quick burst of speed to avoid any immediate danger, though the energy cost is great. Bloatpemum, a fellow grazer, spends as much of its life as possible airborne, never staying in one place for too long as it dives sporadically across the planet's surface. As with any adaptation, this tactic is not entirely infallible, and not all grazers are lucky enough to avoid Rhinomia's toxic grip. Tisuohe-Cring's lesser traveled planets host some of the region's largest creatures, each specialised to thrive perfectly within their environments. Travellers visiting the system will enjoy not only seeing the creatures up close, but exploring the many Galactic Hub built races and games stationed throughout the system. We hope you have enjoyed this documentary. Please like, comment and subscribe to support the crew on the next adventure, and remember to check out the Galactic Hub out there amongst the stars and on YouTube. As always, have fun, stay safe, and most importantly, be curious. Stars. One of the biggest naturally occurring energy sources found in the known universe. Within the 11 regions of Galactic Hub space alone, there are over 1 billion stars. 17% of these support planets that reside within a Goldilocks zone, meaning they are able to sustain life. The energy these stars provide to their planets is crucial to the health of the ecosystems they sustain, and without their presence, life simply could not exist. This is Hub 119C, a system of 6 planets found within the non-lopsy instability of hub space. The energy from the system's powerful M-class star is passed through each of its planet's ecosystems via the food chain, transferring from plants to animals and back in a never-ending cycle. Paragon Prime, Hub 119C's only paradise planet. Gentle, grassy hills give way to plentiful lakes and rivers, providing the perfect backdrop for the myriad of plant life that covers the surface. Each plant species harnesses the energy from the system star for photosynthesis in the form of UV light. This abundance of light energy allows the plants to produce food quickly, growing fast to keep up with the demand of the planet's many herbivores. The most common of these plant eaters is the planet's only mammalian species, C. Bustopium. They live in small herds scattered across the planet, browsing the verdant grasslands in search of plants of a particular age. Plants that have been photosynthesizing for longer contain more energy than fresh shoots, and the species feed exclusively on older plants to ensure that they always get enough to eat. Despite their somewhat threatening appearance, C. Bustopium are an incredibly gentle species, their sharp horns serving primarily as decorative ornaments, useful in attracting mates. As the most common grazer on the planet, the species are often targeted by the planet's carnivores. Their striped fur coat helps to camouflage them amongst the tall grasses. However, this is not always enough to conceal them from hungry eyes. This is Vanadane Frusia, Paragon Prime's expert ambush predator. Their hunting technique relies heavily on stealth, and a mottled hide affords them adequate camouflage amongst the planet's dense foliage. Possessing a high intelligence, the species are incredibly selective when choosing their next kill. Critically eyeing their prey from afar, they often seek out the largest member of any herd, knowing that this will provide them with the most satisfying meal. They position themselves as close to their target as possible, waiting for their opportune moment to strike. Although not quite top of the food chain, they are extremely vicious, their sharp claws and teeth ideal tools for hunting. Vanadane Frusia are not the only carnivores on the planet, and are in fact prey themselves, for Paragon Prime's apex predator, Skip-lid Halika. Sitting at the top of the food chain, Skip-lid Halika hunts opportunistically, feeding on carnivores and herbivores alike. The species are gifted runners, and are capable of reaching speeds exceeding 500 UPH, faster than any of the planet's other land animals. Abandoning the stealth approach favoured by Vanadane Frusia, the species seems to thrill in the chase, announcing their presence to grazing herds with a distinct, loud roar. Although safe from being hunted themselves, skip-lid halakha are relatively rare, the ecosystem unable to support a large population of these voracious feeders. As the energy from the system's star is transformed and passed from plants to herbivores to carnivores, only around 10% is available at each level for consumption. If plants absorb 10,000 kilocalories of energy directly from the system's star, only 1,000 kilocalories of that energy will be passed on to the planet's herbivores. This pattern continues throughout the food chain, meaning less energy is available the higher up the chain you go. Being the third or fourth in line, by the time skip-lid halakha feeds, very little energy is provided with each meal, limiting the number this species can reach within its ecosystem. This forces the animal on a never-ending hunt for food, to ensure they get the energy they require to survive each and every day. The flow of energy throughout Paragon Prime's ecosystem is typical of each and every planet that supports life, and as with all things in nature, requires a delicate balance to remain healthy. At the very end of any food chain sits microscopic organisms known as decomposers that feed upon the remains of both plants and animals after their death. These organisms break down waste energy, transforming it into precious nutrients, vital in feeding the planet's next generation of plants. Without the energy from Hub 11-9C's star, life simply could not exist on its planets. Stars themselves are not eternal, and their death brings on the end for all life in the planetary systems they once sustained. Some civilizations are able to flee their failing star system before its collapse, living in the void of space in mechanical biospheres, searching for a new stable system to call home. Thankfully, Hub 11-9C's star is relatively young, meaning life will go on for millennia before it is at risk of stellar collapse. Interlopers wishing to visit Hub 11-9C will enjoy the varied natural splendours of every one of its unique planets, all made possible by the energy of the system's star. We hope you have enjoyed this documentary. Please like, comment and subscribe to support the crew on the next adventure. As always, have fun, stay safe, and most importantly, be curious. Nature is forever evolving and adapting, with new, exciting discoveries being made all of the time. The Galactic Hub Exobiology Core, or GHEC, are pioneers in cataloguing new and exciting species of flora and fauna, allocating each a specific classification based on certain biological characteristics. Their detailed archives contain thousands of discoveries made within the boundaries of Galactic Hub space, and of all of the fauna they have documented, none are as elusive or as ancient as the Shaihuluda. In this episode, we will explore some variations of these enormous sandworm creatures, as well as investigating their deep connection with the planets they inhabit. Welcome to an interloper's guide to the Shaihuluda. This is Eudon Stellar 11, a radioactive planet found within the Nugstor adjunct region of Galactic Hub space. Its contaminated dusty plains are home to 8 species of fauna, including its very own species of Shaihuluda, first documented by the GHEC director, Phaedrus 29. So far, 9 classes of Shaihuluda have been identified, and of these classes, Udonceles falls under the rather grand classification of Wormlord. Shaihuluda found within this category share one trait, being the only known species capable of producing a unique low-frequency humming, barely registerable even on the most sensitive of instruments. Xenobiologists have suggested that these frequencies could enable the Wormlords to communicate with other Shaihuluda within their planetary system, or even within the wider reaches of space. Although all Wormlords share this behaviour, not all of them share their appearance with Udonceles Shaihuluda. Its jaw is made up of 3 stubby mouth parts, giving it the official classification of stubby-headed Wormlord. The species has a very particular diet consisting exclusively of pugnium-rich sentinel walkers. Excessive feeding has resulted in the planet's sentinel population being all but wiped out, leaving the Shaihuluda with very little food. In response, this Wormlord appears to have entered a dormant stage, barely surfacing from its underground abode. Scientists speculate that this could be a clever tactic aimed at luring sentinels back to Udoncella once more, so that the creature can continue to feed. Within the Euclid Nebula of Galactic Hub space, another radioactive planet plays host to the Shaihuluda. This is Oyster Rock, locally referred to as the Rupshi System's radioactive abomination. Though its atmosphere is highly ionized, it supports a surprising number of animal species, each specially adapted to survive the planet's extreme conditions. Among them is Oyster Rock Shaihuluda, first documented by the Galactic Hub researcher Carolus Magnus 01. Of the 9 classifications of sandworm, Oyster Rock Shaihuluda is best described as an immortal worm. To understand this classification, we must first understand the archaic meanings of the words immortal and worm. In ancient tongue, immortal was a title given to guards and protectors of precious things. The immortal worm Oyster Rock does indeed fill this role, protecting the planet and its unique animal species from detection by outside sources. It achieves this through its diet, consuming planetary beacons and any other device that could broadcast the planet's location, allowing its species to thrive uninterrupted for millennia. The second word of this Shaihuluda's classification, worm, historically referred to a mythical dragon-like reptile. In the case of Oyster Rock sandworm, this perfectly describes its head shape, which is similar in appearance to dragons of old myth. It is known that Shaihuluda seem to thrive in radioactive environments, though these are not the only planets in which they can be found. Returning to the Nugstor adjunct region of hub space, we turn our attention to the blighted planet Ronfori Prime. Its toxic soil is home to a large mycelium network that covers the entirety of the planet, made evident by the abundance of mushrooms growing on its surface. The Shaihuluda inhabiting this planet was documented first by Phaedrus 29, and is classed as a gargantuan due to its immense size. The planet's loose soil aids the sandworm's progress deep underground, as it burrows to depths of up to 127 kilo-units. Here it gains access to rich mineral deposits that make up the entirety of its diet. A large glowing eye covers 60% of the creature's head, helping it to locate these minerals through the persistent gloom underground. So far in this episode, the Shaihuluda's presence has been beneficial to the environments they inhabit. This, however, cannot be said for Runfori Prime's glowing eye gargantuan. Its deep burrowing, facilitated by bony spikes that line the sides of its body, create vast chambers underground. Over time, the sodden soil has begun to recede into these crevasses, creating unstable ground on the planet's surface, destroying the mycelium network running below. This activity continues to reshape Runfori Prime's landscape, and the effect this will have on the future of its native animal species requires further study still. As well as being equipped to thrive in radioactive and toxic environments, Shaihuluda are also adept at surviving in extreme heat. This is the Anzakai System's lava planet, Newtown, found within the Savanex instability of hub space. Its unique, superheated landscape is home to 13 animal species, including a Shaihuluda first documented by the GHEC researcher Glitterbead. Of all classes of Shaihuluda currently documented, Newtown's is categorized as an unstoppable nematode. This classification is given only to the hardiest of Shaihuluda, as they are capable of withstanding the most extreme environments and obstacles. Where others of the species may avoid layers of hard rock and magma, an unstoppable nematode can burrow straight through, experiencing very little resistance. Newtown Shaihuluda holds the record for the shallowest burrower so far discovered by the Galactic Hub. On average, it is never seen burrowing any deeper than 10.5 kilounits. Many tiny legs help propel the creature just beneath the surface of the planet as it seeks out its sentinel prey. As is the case with the wormlord Eudoncella, immoderate feeding has resulted in a dip in available sentinels for consumption. Instead of entering a dormant phase, the unstoppable nematode migrates, moving around the planet to give sentinel forces a chance to regroup before it returns to feed. Of all biomes favoured by the Shaihuluda, the rainy planet Tygon Minor 5 is an unusual choice for a species that seems to prefer extreme environments. Its lush orange and green grasslands maintain a comfortable temperature all year round, interrupted only by occasional mild rainstorms. This is the planet Shaihuluda, a ceaseless burrower first documented by the GHEC researcher Norbelo. The ceaseless burrower class are rarely seen above ground, as they spend the majority of their time burrowing beneath the planet's surface, a characteristic that helped them earn their name. Tygon Minor supports 14 animal species, the largest of which serves as the Shaihuluda's main source of food. Its lips contain highly sensitive taste receptors that enable it to locate its prey from deep underground by analysing the taste of the soil. At first glance, this feeding behaviour may be seen as a detriment to the planet. However, the Shaihuluda helps to keep the ever-expanding population of Jacklacum in check, maintaining the ecosystem's delicate balance. If there is one thing that all Shaihuluda have in common, it is their continuing ability to astound us. Their presence, though not always beneficial to their environment, remains an awe-inspiring experience to all lucky enough to witness their passing majesty. We hope you have enjoyed this documentary. Remember to subscribe to support the crew on the next adventure and hit the notification button so you don't miss the next installment of an Interloper's Guide to the Shaihuluda. Thank you for watching, have fun, stay safe, and most importantly, be curious. mountains. Proud monuments that serve as reminders of a planet's history of extreme geological activity. One of the most impressive mountain ranges so far discovered in Galactic Hub space resides in the Guana Sedge 3 system, found within the Canthian region of the galaxy. The surface of its rotting planet, Egayptim K6, is almost exclusively covered with steep mountain peaks, a unique topography that speaks of the planet's turbulent past. Many of these peaks are the result of tectonic plate collisions, the pressure of which forces the planet's crust upwards, creating the fold mountains dominating the surface today. Others that were once active volcanoes now lay dormant, their hollow interiors transformed into extensive caves that support a variety of bioluminescent flora. Interestingly, these caves are very narrow, having been formed via intense lava flows rather than the more gentle erosion process of water. These inactive lava chambers provide safe refuge from the planet's corrosive cyclones, as well as acting as a thoroughfare between otherwise isolated areas of the lowlands. Scattered amongst Egayptim's mountains lie small pockets of flatland that cover around 3% of the planet's surface. Rainwater caught on the mountain slopes flows down into the lowlands, feeding the shallow lakes and streams that attract large animal populations. The planet's species are almost exclusively herbivorous, and the smallest of these herbivores is never found far from the water. This is Insectletono, first discovered by the interloper Rebeccan. Their miniature stature makes travelling around the planet a laborious endeavour. As a result, the species spends most of their life confined to the bounds of one small area, their habitats usually located within easy reach of drinking water and a cave. Egayptim K6 is plagued by regular cyclones that whip up fine ammonia particles from deposits on the surface. Once airborne and atomized with the rainwater, these particles become highly corrosive, capable of attacking the soft tissues of the planet's inhabitants. Insectletono's AIs are particularly vulnerable to exposure, and as such, the species has developed an acute sense of atmospheric pressure changes, enabling them to predict the incoming corrosive storms. When they sense one approaching, the species retreats underground, to wait in the sheltered safety of nearby caves for the storm to pass. Other species on the planet have been observed following Insectletono underground, seeming to know that their rapid departure indicates the arrival of adverse weather. The lowlands that the Insectletono call home attract many other animal species, drawn in by the abundance of both food and water. The low elevation of these areas keeps temperatures at a comfortable 19 degrees centigrade all year round, only dropping to -8 during the planet's storms. Areas of greater elevation on average experience much cooler temperatures, dropping around 10 degrees with every 1,000 feet. 2,000 feet above the flatlands, small alpine plateaus lay nestled amongst Egayptim's mountain peaks, supporting a small variety of animals. These animals endure temperatures of around -5 degrees, which can drop as low as -12 during the planet's cyclones. The most common of Egayptim's alpine species was first discovered by one of the ApatheticApes documentary crew, frosty toes. This is Oilpedi, the planet's only nyctarovore. An inherently restless species, Oilpedi are constantly on the move, a behaviour that helps keep them warm in the alpine temperatures. A dozen tentacles carry the creature across the planet as they search for the nectar of local flora that makes up the entirety of their high-sugar diet. These plants are rarely found in the lowlands, preferring the cooler temperatures of the planet's high-altitude plateaus, drawing many Oilpedi to their secluded heights. The species are well equipped to deal with the planet's extreme conditions. At their centre, a hard keratin shell protects their vital organs as they travel, doubling as an emergency shelter during the planet's storms. When a storm hits, they retract their tentacles inside this shell, protecting vulnerable flesh from damage. Egayptim K6 supports 12 native animal species, and all but one are of a biological nature. This is Trogame, the planet's only biomechanical species, first discovered by Rebeccan. The species is found all over the planet at all elevations, and feeds exclusively on microscopic organisms found within Egayptim soil. The metal plates lining their bodies scoop up dirt as they roll, filtering out these organisms and returning excess soil to the planet's surface. The microorganisms are absorbed through a thin membrane at the creature's centre and directed into its concealed mouth. A nomadic species, Trogame are capable of travelling up to 500 kilo units a day, and often do so in the company of others within small, tight-knit herds. This species alone seems immune to Egayptim's corrosive storms, and continue their relentless search for food regardless of the weather. The inner core of their body radiates a soft glow that is intensified during the planet's storms, making them easy to spot through the swirling dust. Trogame use this to their advantage, their bright bioluminescence acting like beacons to ensure members of the herd don't get separated from the group. The mountains of Egayptim provide diversity within its ecosystem, the elevation directly affecting the temperature and precipitation of its biomes. They provide shelter for the planet's inhabitants from the regular cyclones that rage across its surface, as well as providing the main source of fresh drinking water for many of the planet's native creatures. Despite the raging storms and steep, unforgiving peaks of Egayptim K6, the planet remains a hotspot for thrill-seeking climbing enthusiasts across the galaxy. So far, only a handful of interlopers have managed to crest the peak of the planet's tallest mountain, a peak that stands over 6,000 feet. It is christened Mount Eddy after the interloper that discovered the Koana Sedge 3 system, Eddy's High Hide. We hope you have enjoyed this documentary. Remember to like and subscribe to support the crew on the next adventure, and as always, have fun, stay safe, and be curious. Throughout this series, we have discovered many unique animals and explored the complex relationships they each share with the planets they inhabit. If you have enjoyed this journey through Galactic Hub space as much as we have, subscribe so you don't miss any of the upcoming releases. In this final episode of Season 2, our expedition takes us to the Dexterf sector of the Euclid Galaxy, to a planet ruled not by plants or animals, but by something else entirely. This is Yoxisrapa, one of 2 paradise planets found within the Oknuts 10 system. It is known locally as Oknuts' second sun, the reason for which only becomes apparent as night draws in. Yoxisrapa supports the largest and most diverse population of bioluminescent fungi so far discovered in the Galactic Hub space. Fungi are neither plant nor animal, and are in fact classified as a life form all of their own. The main body of a fungi organism lies underground, extending in a vast network that runs throughout the planet's soil. This root-like network is called mycelium. The mycelium functions as a courier, transporting both nutrients and information to other areas within the network. The mushrooms dominating Yoxisrapa's grassy surface are all connected to this network and serve as the fruiting body of the organism. The mushrooms release spores into the environment to further the area of growth of the mycelium network below ground. Yoxisrapa supports 13 species of mushroom, and each one has its own special technique when it comes to spreading spores. This is Grabonium, a species of mushroom that dominates Yoxisrapa's grasslands. In its infant stages, the mushroom's conical cap is a pale pink. As it matures, the cap transitions to a more vibrant yellow, an indication that it is ready to spore. In this sporing stage, it is called Costivis. Unlike other mushrooms, the Jamur mushroom releases spores in a thick tar that drips onto the surrounding soil. The bioluminescence and bright yellow colouring of its cap encourages insects and animals to approach it throughout the night and day. As the creatures brush by, the tar sticks to them, ready to be transported far and wide across the planet's surface. Once the Costivis has finished sporing, it releases an autodigestive substance that consumes its body, returning nutrients back into the soil. These nutrients are then gathered by the mycelium below and absorbed back into the fungal network. Mushroom spores are incredibly resilient and can remain dormant for thousands of years. Yoxisrapa is home to an incredibly rare species that can only be awoken from its dormant slumber by the chance strike of lightning. This is Tentamere. This particular specimen, according to botanical analysis, remained dormant for approximately 3,000 years before lightning activated its inert cells. Unlike the Jamur mushrooms, Tentamere can live for long periods of time and have been recorded to live as long as 100 years. Their spores are released regularly from multiple ovate caps at the top of their stem. The wind carries the spores across the planet, where they wait patiently for lightning to strike. The spores are incredibly resilient and can withstand almost any environmental change. Yet, out of all these released on Yoxisrapa, less than 1% would have the chance to grow into the Tentamere mushroom. Tentamarae, like many of Yoxisrapa's mushrooms, uses bioluminescence to attract creatures that can aid with spreading their spores. But where does this light come from? Within the mycelium network, the molecule luciferin is passed throughout the chain. As the mushrooms absorb this molecule, they draw in oxygen. This causes a reaction, resulting in a soft bioluminescent glow. For the Skinrefo, however, this is not the case. It is incapable of ingesting luciferin itself, so has developed a clever trick to get a light all of its own. The center of its funnel cap is filled with a sweet nectar favored by one particular species of bioluminescent bacteria. In return for providing the abundance of food, the Skinrefo benefits from the bacteria's bioluminescence, using it to attract animals that can pass on its spores. Without this bacteria, the mushroom would be much less successful in attracting pollinators, in comparison to its bioluminescent competition. Yoxisrapa's mycelium network does not only pass nutrients to and from its mushrooms. The planet's grasses also hook into this network, exchanging excess sugar for nutrients. The luciferin flowing through the network is absorbed into their cells, giving the grass its fluctuating glow. Another beneficiary of the mycelium network on Yoxisrapa is the humble star bramble. Native only to lush climates, they are most commonly grown via hydroponic systems on an industrial scale. In fact, star bramble farms are a large part of the galaxy's agricultural market, owing to its many uses in crafting and food processing. On Yoxisrapa, star brambles are able to flourish thanks to the abundance of nutrients shared within its vast mycelium network. Star brambles on Yoxisrapa, however, do appear to glow brighter than those grown industrially, thanks to this connection. This increased light allows them to better attract the insects that will pollinate them, allowing them to grow in greater numbers. On Yoxisrapa, plant, animal and fungal life are all connected, each living symbiotically with the other. The beauty of its bioluminescent landscape and gentle weathers is not all that brings interlopers to visit. Yoxisrapa is home to one of the largest archives in the Dexturf sector, containing information on many of the local galaxies and their native inhabitants. Interlopers wishing to visit the archive can do so at these coordinates. We hope you have enjoyed this episode and this season of Interloper's Guide. Remember to like and subscribe, and click that notification button so you don't miss the start of Season 3. Thank you for all your support, and as always, have fun, stay safe, and most importantly, be curious.